Day-to-night image synthesis for training nighttime neural ISPs. Imaging under daylight is easier because the scenes are brighter, dominated by a single illuminant, and minimally affected by noise. In contrast, nighttime scenes are much darker, contain multiple light sources, and suffer from high levels of noise, particularly in smartphone cameras. Many flagship smartphones now use a dedicated neural night mode ISP to render the noisy raw data and produce a clean nighttime image. The neural ISP is trained using pairs of noisy clean images. It is very challenging to obtain such real paired training data. Typically, hundreds of image pairs have to be collected. The camera and the scene have to be static to avoid motion blur. Moreover, since raw images are sensor specific, training data has to be recaptured for each new sensor. We propose a method that takes daytime images, which are much easier to capture, and converts them to nighttime images. In particular, we propose a processing framework to convert daytime raw images to aligned pairs of noisy raw and clean rendered nighttime images, which can be used for training night mode neural ISPs. Our method eliminates the need for paired data capture and does not require the scene and the camera to be strictly static. Our pipeline begins with the daytime raw image. We first normalize the sensor data. Compared to other illuminations, images captured under daylight incur the least error in terms of overall color correction when white balanced. This is why we specifically select images captured outdoors under daylight to apply our synthesis model. We remove the day lighting in the image by applying the white balance as the next step of our pipeline. Next, we lower the exposure of the daytime image by multiplying it by a random global scale factor. We locally relight the scene using a small random set of night illuminants with random locations and fall-offs. We finally denormalize the image to obtain our synthetic nighttime image. Adding noise produces a noisy raw nighttime image, which is the input to train the neural night mode ISP. We can also process the clean nighttime raw image through the ISP to produce a clean rendered nighttime image. This image serves as the target for training. These aligned noisy clean synthetic nighttime images can now be used to train a night mode neural ISP. We use a Samsung S20 FE smartphone camera to capture a dataset of daytime images and a dataset of nighttime bursts for evaluation and testing. We compare our method against various baselines that use synthetic data. Please see our paper for details. We also compare against cycle GAN and a fully supervised approach that is trained on real paired nighttime data. Our approach produces better results than the baseline methods and cycle GAN. Furthermore, our synthetic nighttime images, together with small amounts of real data, yields performance on par with training exclusively on real nighttime images. Here, we show some qualitative results of our method along with comparisons. To conclude, we have presented an approach to convert daytime images to pairs of noisy clean nighttime images. Our method is very useful for data augmentation and significantly reduces the time and effort required to prepare training data for neural night mode ISPs. Thank you.